All right, yeah. So my name's Jonathan Sullivan. I'm a PhD student in the School of Natural Resources and the Environment, and I'm here to talk to you about flooding. And in the spirit of the conference, I sort of posited a question that I don't necessarily know the answer to, but is a question to the audience of can predicting social and physical flood vulnerability illuminate invisible threats? And this is a collaboration with a number of other PhD students through an organization called Cloud to Street. So there are a lot of my collaborators up there. So to contextualize the problem of flooding, we know that approximately 21 million people annually are at risk of flooding events. And that occur, 80% of that population is within 15 countries. And a lot of those countries are developing countries that lack capacity to respond to floods and also lack information to respond to floods. But this problem isn't only unique to developing countries, it also exists here in the United States where we have extraordinarily old flood maps. So every green point on that map is a FEMA flood map that's over 25 years old. And that's over high-risk areas in red across the United States as well. And I think this really came to a point after Hurricane Sandy where it was clear that a lot of the maps in that hurricane were over 30 years old, and approximately 10,000 homes that were affected were outside those maps. And so this is really where the organization Cloud to Street, we hope to step in and be able to bring affordable flood information that can be quickly updated. And so the way we do this is through a number of methods. First, starting on the left is using satellite imagery. We use something called Google Earth Engine, which is a massive repository of satellite imagery. And we cross that with information on where and when flood events have occurred, and we're able to map that. So on the bottom left is some work that we've done in Senegal, and we've detected up to 6 different flood events from 2000 to 2014. And you can see a lot of those are occurring along riverine areas where the populations are living. We also extend that to a level of predictability with machine learning hydrology. We do this using a number of different variables like precipitation. So when we increase from 1 inch of precipitation to 2 inches of precipitation, what's the change in physical vulnerability? Land use changes, elevation, slope. We put all these into machine learning models to be able to predict where flood vulnerability will occur in the future. And lastly, social vulnerability. We understand that not every area that flooding occurs is equal across groups. And so we use something called the Social Vulnerability Index, or the SOVI index, that was developed by Susan Cutter to map areas that have high social vulnerability. And to really drive home this point about social vulnerability, and it was sort of an aha moment for the group, was we were doing a project in Albany, New York, and we were across this 45 tract census data of 45 tracts with a flood event that occurred in Albany, and using the SOVI index, we ranked different socioeconomic variables that make different census tracts vulnerable to floods. And we happened to be with a friend in the room at the time, and they said, "Hey, I'm from Albany, and I don't really understand why that area is listed as highly vulnerable." And so we looked in Google Maps, and we noticed, oh, gee, there's actually 3 nursing homes in the area. And that was something that our model picked up. And so we started to understand that we could actually have some predictability of what groups might actually be vulnerable to these flood events, and we can also predict where flood events may occur. So we're doing a lot of work to improve the machine learning hydrology models, to improve the SOVI index. One work that I'm particularly involved in is mapping globally all the historical flood events that have occurred since 2000 to present day. We're doing this using Google Earth Engine, and also working with the Dartmouth Flood Observatory that have information on when and where flood events have occurred to make a global map of historical flood events.